thanks to all of you for coming out, and thanks to all the conference organizers and everyone else who helped make this event possible. So today I'll be talking about how I use Dash to create an interactive application for a firefighter to collect sensor data while he was testing one of their pieces of equipment. And then towards the end of the talk, I'll talk about some key takeaways that I've had throughout the project so far that can be applied to creating these kinds of apps, specifically for non-technical audiences. So a little bit about myself. I'm a research engineer with Underwriters Laboratories. And so for those of you who aren't familiar with UL, we do a lot of things, but for the most part, we're a safety certification company. So we do a lot of consumer products testing. So if you look on everything from smoke alarms to your computer chargers to the exit doors in this building, if you look close enough, chances are you'll find the UL logo on there. UL is a pretty big company. We have over 14,000 employees in nearly 50 countries around the world. And working for them has just been really great. They have a very strong company culture that's mission-oriented towards creating a safer world. And the higher-ups have been very supportive of the work that my group does. And so I'm very grateful for that. And so there's two sides to UL. There's a for-profit side and a non-for-profit side. The group I'm with is on the non-for-profit side, and we're the Firefighter Safety Research Institute. We're based out of Columbia, Maryland, and our main goal is to conduct research that's focused on advancing the knowledge of fire behavior throughout the fire service, and as our group continues to grow and expand throughout fields that are adjacent to the fire service. So my job, along with other engineers in the group, is essentially to light things on fire. It's pretty fun. And then study and measure what happens, analyze the results, and share the results with our stakeholders. We're essentially a group of pyromaniacs who've channeled our urges towards the greater good. And I feel like now is a good time to just mention that I had nothing to do with the fire alarm activation last night at the hotel, for those of you who are staying there. So I thought I'd share this quick 30-second video from experiments that we conducted this past July in Cobb County, just outside of Atlanta, Georgia. It was made by our extremely talented content developer, and it'll kind of give you a better idea of what it's like when we're out in the field burning things. So as far as programming experience, I have what I would consider a casual programming background. And by that I mean, when I was an undergrad, I took some courses where I had to learn C and C++ and LabVIEW, MATLAB, et cetera. But by far the language that I use the most and that our group uses the most is Python. And as far as the level of Python user, I guess I'm at the intermediate level. Basically, I know enough to know there's still a whole bunch of Python topics, especially in terms of optimization and best practices that I can learn. The libraries that I use most and that our group uses most include NumPy, Pandas, Matplotlib. And we generally use Python for data analysis, post-processing, and generating plots like the one you see here for reports. So pretty simple plots, but anytime an opportunity comes along for me to learn something new, especially with Python at work, I tend to jump on the opportunity. For example, just finishing up a project where I used TensorFlow and OpenCV to extract flame height data from experimental video. And then we were able to compare that flame height data to predictive models and algorithms that fire investigators use when they're trying to recreate a fire. And so this desire of mine to always looking for something new to learn in Python is part of the way I got involved with this project. So I'll start today with some background and motivation about the project. And then I'll give a brief overview of exactly what Dash is and show some examples to give you a better idea of its capabilities. Then I'll discuss the dashboard that I created, which is called the AZV dashboard. And I'll give you a quick overview of the dashboard from its beginning to its current version now. And lastly, I'll finish with some key takeaways. So I became involved with this project through my work at UL. One day, one of my coworkers pulled me into his office, and he started telling me about this firefighter named Kelly who was on a rescue squad in Washington, D.C. And just a quick aside for those of you who aren't up to date on your firefighter lingo, a rescue squad is a group of firefighters who are not only proficient in firefighting skills, but also technical rescue skills. So they respond to all kinds of events that involve the need of their skills. For example, if somebody flips their car on the highway and becomes entrapped, or if someone falls off an embankment, more likely than not, some of the first firefighters to respond will be from a rescue squad. So anyway, Keith, my coworker, was telling me about this guy named Kelly, and he had this tool he's been looking at known as the Arizona Vortex, or AZV for short. It's basically this tripod-looking thing here, and it's designed to keep ropes off the ground to protect them when workers are performing rescue operations. And essentially, they mount pulleys to the top here and then run ropes through and put them in tension and then perform whatever rescue operations they're working on. And it's very important to know the distributions of the forces on this device, because if it's not used properly, it could topple over. Obviously, that's not good. And one of the things that makes this device unique is that not only can it be used with 3 legs, but there's configurations that can be used with 2 legs, or there's even one where it's just the pole. And so as this device has gained popularity over the years, people have been wondering all sorts of things about it, like what are the magnitudes of the forces on the different legs? How do those forces vary between the different configurations? And how close do they come when they're using it to the rated limits of the device? And so as people do trial and error and start messing with the tool, they start making claims, and Kelly kind of wanted to see how valid these claims were and have actual data to back them up. And so having no real background in electronics or data acquisition, Kelly took the initiative and did research and bought some load cells and a data acquisition device, and eventually was able to rig up the load cells to each leg and get some data. But a lot of times in research, you get the initial data, and then that just causes more questions. And so he asked Keith, my coworker, if he knew of anyone who'd be interested in kind of taking this project to the next level. There were a couple things he wanted to do with it. And so Keith reached out to me, and I immediately jumped on the opportunity, thinking it would be a great opportunity to learn how to use Dash. And so by a quick show of hands, who here has heard of Plotly Dash? All right, cool. So for those of you who haven't, it's a library from Plotly for creating analytical web applications. It's written on top of Flask, Plotly.js, and React.js. And the real power of it is that you can create these applications solely through Python. And so I have a quick example pulled up from the Dash app gallery that I can show all of you to give you a better idea of what this tool is capable of. So just real quickly, this is the Dash app gallery. There's about 45 different applications that are all for different purposes, from data analysis to financial report creation. And lost my cursor. So this is an example that I have pulled up. You can see there's all sorts of interactive components. There's sliders, there's drop downs, and depending on what you choose, the data responds accordingly. The plots update. You can do maps, and have hover capabilities that, again, this plot here responds to it. These are all Plotly graphs, so they're fully interactive. And so if you just take a second to think about what would be needed to create something like this, if you were to create something just without using any sort of tools like Dash, you would need to know JavaScript. You probably have to know some CSS to make it look nice. You have to write your own server. Probably need React and a bunch of other things that I'm not familiar with. So this is really the power of the tools that you can create this all through Python. And also, as I'll show in a second with this simple example that I made, the structure of the code is very straightforward and simple. And so now I'll move on to the dashboard I created. So after I heard about this project, I decided the first step should probably be to at least look at Dash and start learning it. And I found that the user guide was a great place to start. They have some very simple examples, and that they go over the structure of the code. And so I also received a few data files from Kelly, and I figured I would make a very simple application for our first meeting, just to kind of show them what the tool's capable of. And so I'll show you one of those applications that I made, just to give you an example and go over the code structure very quickly. So this is the application I made. It's very simple. You just select lost my cursor again. You select the data file from the drop-down menu, and then it creates graphs of the voltage and then the load data from the data file. And so this is the code that creates this app. Import all your packages. This is basically just grabbing the data file names from the directory. And then this initializes your app. And there's really two parts to Dash code. There's the first part here that defines all your components. So if you look over here, there's really three components. There's the title, which is defined by this line. Then there's the drop-down. And lastly, there's your output graph. And the second part of Dash code is how the defined components up here interact with one another. So they have callback functions, and the second entry is the component and the part of the component that will trigger this callback function. So here it's the value of the drop-down. When that changes, this function below will run. And then the first input is what's going to be updated as a result of this function below. And so in this case, it's going to update the children of this output graph object. So basically, this function just reads in the data file, and then it returns two graphs. And so this DCC is Dash Core components. They have a whole bunch of different components that you can use, so that they have like graphs and buttons and indicator lights, all sorts of things that you're able to implement into the application that you're building. So after I created those couple examples, I met with Kelly, and he introduced me to the project and showed me the progress so far. And then we kind of discussed where we wanted the project to go, what the goals and purpose of the project were. I demoed those examples for him and kind of described different capabilities offered by Dash, and we brainstormed kind of what the next direction or the next things we wanted to implement, and we developed a list of initial objectives. And so the initial objectives we came up with was basically we wanted this to be able to read in a data file and then output the sensor values in real time and generate plots after the test was completed. And the interface should be straightforward and easy to use. So the first version that I created was focused on functionality and keeping things simple. And this proved challenging at times because the more I used Dash, the more I loved it, the more ideas flowed in. But instead of falling down the rabbit hole of trying to implement the ideas immediately, I just scribbled them down on a piece of paper and took notes and to have and try them at a later date. So then once I had a version that was up and running and fulfilling the objectives, I met with Kelly again and we demoed it and more ideas flowed in. And he told me what was good, what could be removed, and we prioritized more goals for the next version. And so this latest version has a number of improvements to it. First of all, I decided it would be a good milestone to kind of take the time to clean up and improve the code, just so it'd be easier as I add things. And then I also enhanced the styling and aesthetics a little bit. I changed the layout of the page from the table layout to Flexbox. I was able to scale down the fonts so they would change size with changing window size. I created a CSS file to organize all the different styling components. And I added some logos at the top and improved the graph and plot style. And I added some animation to buttons for when you hover over them. And then I also added a couple features, event logging and display of values. So when it's logging real time, it's the real-time value, and then in the post-test dropdown, it's the maximum value that displays. And just to give you better idea of what the first version looked like compared to the second version, this is the first version. And you can see it has kind of the functionalities we talked about. This is the post-test plot, so it's just essentially another version of the simple example I showed earlier, where there's a drop-down and then plot appears. And you can see, I mean, it gets the job done, but the lines on the plot are pretty thin. This font's kind of small. This drop-down's unnecessarily wide. And so this is the latest version, the same tab. And you can see we now output the maximum values. The lines are thicker, the font's a little larger, and there's pretty logos up here at the top. And so now I'll show a quick demo of the dashboard in action. So there's a number of things that the user needs to input on the Setup tab. There's a channel list of all the possible channels on the DAC device. And then when the user selects them, the field under this populates, and you can enter custom names. So I'll just enter and so on. Then there's a list of additional inputs, including the data type in case he starts using sensors in addition to load cells, the units that you're outputting your data in, the frequency of the data collection, how long you want your background time to be. We'll just do like 5 seconds. So then that zeros the load cells before it starts collection. And then the output file name. And then once all the fields are populated, the user can go ahead and hit Start Data Collection. And it creates an info file that has all these inputs. And then we can switch to the the real-time tab, and that has the plot in real time. You can see the values are being displayed in real time. The event logging that I added is this button here. So you can type in an event and then hit the event, and you can see the load cell responds. So I'm pushing on it now, and it's in compression, and if I pull, it's in tension, so it's positive. And same thing with load cell number 2. And then once you're done doing whatever you're doing with the AZV, you can hit End Data Collection, and it stops the collection. And then you can go over here to the Post-Test tab, select your file, and look at the plots. And again, these are all fully interactive plotly graphs, so if you want to, you can download it as a PNG. You can zoom in on certain values and do a number of other things. So some upcoming improvements that we're looking at incorporating. Number 1 would be a button that zeroes the sensors during the test. And this is because after talking to Kelly, he was saying that they'll get the device set up, and then they'll get the ropes run through, and then they tension the ropes, and they'd like to zero it then so they can see what fraction of the force is due to the tensioning of the ropes and then what fraction of the force is due to its actual usage. Another improvement that's in the works is a sensor calibration tab. So essentially get the calibration constants for the load cells by applying different weights to them. And then add indicator lights and a time ticker to let you know when you're in real-time plot mode. And it's about, the dashboard's about at a point where I'm comfortable giving it to Kelly for him and his firefighter friends to use, so I'm sure they'll find a bunch of bugs that need to be resolved. And then eventually we want to add the capability for wireless data logging. I'm thinking about using probably an Arduino to do this. Now I'd like to briefly go over some key takeaways that I've had from this project. So one thing I found that was very helpful is developing clear objectives from the start. You need to figure out what your audience wants. It's very important to remember that in a lot of cases, your audience doesn't know what they don't know. So if you can help them out by providing details of what the tool's possible of, that's a good way to get them to come up with ideas and see things that might give them ideas of things to implement. And so some good resources for that is the Dash app gallery that I showed, and also just trying to create a couple examples by yourself so you become familiar with the product. And just start simple to hit the ground running. Try not to go down rabbit holes of implementing complicated ideas or things you're not familiar with until you have a better grasp on a product that actually works. And be sure not to overpromise, but at least not too much. I know some people like to overpromise, or just have the habit of overpromising because it motivates them, myself included. But it's just important that if you do and things aren't going the way you want them to, that you keep in continuous contact with whoever your end user is and to communicate and receive feedback from them often. And it's also important that you take clear notes throughout, whether it be chicken scratch, like in the moment, and then you go back and organize it into neater writing that you can actually read. And you should take notes from ideas you have when you're demoing for the end user, and as you develop code, anything that comes to mind. And anytime you create something that works, but you know that it could be drastically improved, be sure to make a note of that. And then as you're going about, make sure you rank them in order of implementation so you can start with the low-hanging fruit and then work your way up. It's important that throughout the development you revisit your objectives specifically when you demo it, and revisit the objectives with your end user. Just make sure you're on the same page and that your ideas sync up with his or hers. And then be sure to take time to clean your code when you reach certain milestones, because otherwise, as I'm sure you're all familiar with, you'll end up going through thousands of lines of code and you have no idea what's going on. And the most important thing is to just treat it as a learning experience, especially if you're unfamiliar or not really that familiar with Dash. There's a bunch of great resources out there to help you get started. The user guide, like I said, is a good place to start. The Dash App Gallery, that's also good. The Dash App Gallery is something good you can share with your end user to get them thinking about ideas. And then also there's a whole bunch of online tutorials on YouTube, and pythonprogramming.net has a really good 5-part series, I believe, that kind of helps you go through creating your first application. And with that, real quick note, if you want to spice up your Twitter feed, be sure to follow our group on Twitter, the handle right there. You'll get some cool fire pictures, and you'll get updates about the work we do. And that's about it.
Because you were writing in Python most of the time, or all of the time, and it was sort of writing JavaScript and also React for you, were there times when you felt that you were fighting, you had to fight the code that it was generating for you, whether it be the CSS or the JavaScript?
No, but I don't know if that's I would like to think that it's a product of Dash itself, but it could also just be a product of my ignorance of those other tools. But I guess, there are a couple times as I was kind of learning to make a CSS file that things would be different from the Python code itself to the styling, but there was never any time where I really struggled with that, I guess. But.
Hi, thanks for introducing this Dash app, because it is great for someone like me who has a phobia for Node.js and JavaScript and all web app kind of stuff. And I see it has a lot of useful for my projects. But my question is, are you or have you ever heard anyone using the Dash on a serverless compute platform such as AWS Lambda?
I can't say that I have, but and I'm not sure. I would think that's possible. But.
Okay, thank you.
Yeah.
Is it possible to embed a Dash app within an existing website, or does it have to run standalone?
As far as I know, I believe it has to run standalone, but I mean, that doesn't mean that you can't. I just haven't come across something that explicitly says that you can, or seen an example of it.
Thanks for giving the talk. I was wondering about the use of the Dash app in real time during, like in the field for these firefighters. Do you guys just use these in test environments, or are you taking them, or once you implement this wireless communication for these sensors, would you take them in the field and see in practice how that performs?
Yeah, that's a good question. So that's another part of the reason that I started wanting to learn to use Dash, is eventually incorporate into the field testing that we do, and basically do live visualizations of the data that we collect when we're out in the field. So yes, that's a plan down the road, and I'm pretty excited to see the limitations of Dash, because we collect like over 200 channels of data at times when we're out in the field doing those tests. So it'll be interesting to see, and a good way for me to learn about optimization of code as well, because I'm sure that'll have a lot to do with pushing its limits.
Are there any other sensors or any kind of hardware that you have plans for in the future, or that you already are using that something like a dashboard like Dash can provide can apply as well to monitor other types of faulty hardware that the firefighters might encounter or use?
That's definitely a possibility for the future.
Sure.
There's no plans on the books.
Gotcha.
Yeah. And I think I think we need to stop. So if you want to come find me afterwards, I'd be more than happy to answer your question.
Yeah.